Anytime force is applied to rotate an object around a fixed axis, you're applying torque. This includes twisting off a bottle cap, or pushing a door around its hinge, or sharpening a pencil, or even a seesaw pivoting around a central point. In physics, torque is defined as a rotational force applied to a lever arm at a distance from a fulcrum, which is the point around which it rotates. Therefore, a few key parameters determine torque. It's equal to the amount of force applied times the distance between the fulcrum and the point at which the force is applied times the sine of the angle between the lever arm and the applied force. According to these three parameters, there are three ways to maximize torque. Let's say you want to slam your door as loud as possible, for example. First, fast track your fitness gains so you can apply more force. Second, push from the edge of the door furthest from the hinge. And third, apply force perpendicular to the flat surface of the door. Let's reflect more on all this, specifically the relationship between distance and the angle with torque. Have you ever tried closing a door by pressing at a point near the hinge? If not, it would be an instructive experiment, although it might be a bit puzzling to any onlookers. Anyways, it requires a lot more force than pushing the door at a point further away, like somewhere closer to the doorknob. As torque is directly proportional to distance, you can double the amount of torque by doubling the distance at which force is applied. But there's a certain trade-off, as a lever arm must be moved a greater distance when force is applied at a greater difference from the fulcrum. This principle is how wrenches and levers work, and because no discussion of physics would be complete without a mention of the ancient Greeks, this principle reportedly inspired Archimedes to claim, "Give me a place to stand and a lever long enough, and I will move the whole world." Another way to increase torque is to increase the angle of force application to as close to 90 degrees as possible. Here's another experiment you can perform to demonstrate this point, and to convince any observers that you've totally lost it. Go up to an open door and try to close it by putting your hand on the door and pushing it almost parallel along the surface of the door. Then, try pushing directly perpendicular to its surface. You'll see that the second way will be much more effective, and is how we commonly use doors, because a door will experience the most torque when you're applying all your force directly perpendicular to its surface. Therefore, it makes sense to use sine here, because the sine of 90 degrees, when you're pushing directly perpendicular to the door surface, is equal to 1, which maximizes torque. On the other hand, if you manage to push completely parallel to the door surface, that is, at an angle of 0 degrees, well, the sine of 0 degrees is 0, so that action would yield 0 torque.